Welcome back to ICanScienceThat, and welcome to summer, at least up here in the Northern Hemisphere. We know it's winter down south, but either way you slice it, we just passed the June solstice, and with that, we celebrated with some observations. We got together with a bunch of science-interested folks all around the world and did a little observation to see where exactly the sun was on the solstice. And today, let me share with you the raw results of what we got. Now, for today, I'm going to just show the raw data. We're not going to try to draw any conclusions just yet. I just want to get this out there really quickly. So first off, I do want to highlight that this was an effort to bring together flat earthers and round earthers to work together and show that we're all interested in real world observations and drawing conclusions from evidence. And on my little Google form, I did ask the question of what you believe, and those are my results. So I don't want to speculate about why that is. I can think of definitely there are many reasons we should not read too much into this. Also, I want to point out that we do have a flat earth response. The original flat earther who sparked this entire intrigue, Godric, who came onto my channel for an interview, and he suggested we do this experiment. He did participate, he did the experiment, and he sent me his results, but he did not fill out the form. He sent them directly to me, and so I have included his results in the data set. But he does not show here. So what we have is 29 to 1. 29 round participants and 1 flat earth participant. I also heard from one other flat earther, Rachie, who said that it was overcast in her area, and I confirm, I've heard from multiple people who live in that area that they all struggled with overcast during this couple of days we were trying to do this. Now, let's take a look at the raw data. Here we have the results. Now, I am going to make this form public, and I'll put a link down there in the description so you can go and get this data for yourself, analyze it yourself, use it yourself. This contains all of the data that was sent in through the Google form, as well as the data that I entered myself that was sent to me through some other means. It was pointed out to me that some people had entered their latitude and longitude very precisely, and it might not be a good idea to make public lists of people's homes, and I think that was very wise. So what I've done is I've removed the longitudes. We don't need those for anything. I just removed them. And for the latitudes, I've rounded it to the nearest 1/10 of a degree. So I took whatever people submitted, rounded it to the nearest 1/10 of a degree. That's what you see here in the latitude column. I took off everyone's names. Those are not here. And so hopefully that protects everyone's safety and their identity safely. Okay, these are the raw data. Some people provided units. A few people, you can see, did not provide units, and that's okay. If you want to know how long everyone's stick was, you can use the units for those who provided it. For those who didn't, you can guess what kind of units they used. An interesting quirk of the mathematics involved is that you don't need the units for anything. Those units cancel out in this math. So and that's what that's there for. Here is the raw data that everyone gave me, the height of their stick, the length of the shadow. Here I have calculated in radians the angle. This is what you would do with a protractor, and you would probably do it in degrees right there. And so what I'm telling you to do is if you're nervous about my math, you think maybe this math here with this arctangent, it's kind of sketchy, get out a protractor, draw a scale diagram of the height and length of the shadow and the stick, and then get out your protractor and see what angle that comes out to be. Okay, this column here is the calculated angle. This is the angle we expected to get based on the specified latitude. Now, how do I know that? That's the prediction. That's the standard science textbook prediction. And yeah, I mean, I guess it's probably based on a globe model. Certainly that's my understanding, but whether you think it's globe or flat, that's the prediction that I think we have to work with. And here in this column, how far off everybody is in degrees. So most of them are really pretty good, and highlighted in red automatically is any observation that's off by more than 1 degree. So the worst observation right there, and I won't rub it in if you know who you are, but you're off by 3 degrees. So this is not bad. What we're saying here is that this calculated angle, this theoretical angle, we confirmed it to within 3 degrees at the worst, and most people are much closer than that. Yeah, we'll see a trend line for that here in just a minute. The shadow lengths, I should point out, negative numbers. Negative numbers, what's that? How can you have a negative shadow length? Negative numbers indicate south. If the shadow is pointed south, then I put a negative number on here, and that helped me to work out these angles in a sensible way. And positive numbers for shadow length mean the shadow is pointed north. So there's often some math skeptics lurking down in the comments, and I can feel you typing at me right now. You're typing out, length cannot be negative. Ha, math is wrong. Right, well, length cannot be negative, but if I say that column represents how far north the shadow goes, then yes, that can be negative because those shadows point south. So any shadow pointing south does not go north at all. In fact, it goes the opposite of north, which is a negative number. So these negative numbers represent south pointing, and these are from our folks. And you can see the correlation here. Also true of latitude. Latitude that's negative, that's down south. Those are people who are below the equator. So that's our Australian and our New Zealand buddies who are down there taking these measurements. Okay, let's bring in now the graph of our data. Right over here, we've got the graph. Now this is the latitude where the observation was taken on the x-axis, and on the y-axis here, the sun angle. So this is this right here, the angle of the observation in degrees plotted against your latitude. And what do we find? The theoretical expectation was that we would find a straight line here. What do you think? Is that a straight line? Let's in fact, I can ask Google to put a straight line on here for us. Trend line. There's the trend line, and show the r squared. Okay, let's get rid of that so we can see our graph nicely. Okay, what I've just asked Google to do for me on this is to put a line through the data set that is the best fit. So that is the best possible line that describes the data that we actually took. And I think you'll agree our data lies very close to that line. Also, right up here, it tells you the formula for the line that it calculated. This is not the predicted formula. This is the calculated formula based on our measurements. And those of you who know what the correct formula is might recognize that it is very, very slightly off of the prediction. How far off? About half a degree. we're within half a degree. And this, I believe this number is rounded. So maybe somebody who knows Google better than me could tell me, are there any more significant figures past that 114, or are there only 3 significant figures on this? Okay, the r squared is on here. For you math nerds and you statisticians out there who are asking for that, who know what that means, the R-squared value is represents how good this fit is. And that is very, very good. That is telling us, yeah, you know how it looks like a line? That data is a line. So that's what that tells us. Okay, so don't want to draw any conclusions really from this, just want to publish the results. I will publish this. And what do we see? What did we expect to see? We were hoping to find that the sun, the angle to the sun does indeed vary depending on how far north or south you live. We are expecting to find standard science says that we would get a straight line, that this relationship here is a straight line, and we confirmed that. We've confirmed that really well. We got some variation in here within 2 degrees off, 2.5 degrees off, as much as 3.2 degrees off. So I think we can agree that over a data set that varies, now look at this, our data varies from 46.5 to 158 degrees. So over 100 degrees of variation, and within that range, we're within 3 degrees of the predicted answer. So that is really quite solid. The only conclusion I really want to draw from the data at this point is that we have good solid confirmation that the angle to the sun is very close to what was predicted. This matches what suncalc.org predicted, and it matches what the science textbooks say. So without drawing any conclusions about the shape of the Earth yet, or who is telling the truth and who is lying, and who is right and who is wrong, let's not go there yet. What I can say is that suncalc.org was excellent at predicting where the sun's elevation would be based on your latitude and longitude. When you entered your city or your latitude and longitude into suncalc.org, it correctly predicted that time of culmination, or what we called local noon. That was predicted accurately. Also, the angle, the elevation angle of the sun was predicted with extreme accuracy as well. And so that should give us confirmation of those elements at least. We have independently verified that that is now a reliable data source. We only did it on one day, but we could repeat this on other days to expand that confidence. But I think we can start to build our confidence in certain pieces of data, certain factual pieces of data. And one of those is this angle here, that if you tell me your latitude, I can tell you where the sun will be at noon on the solstice. This is now hard data that we have, okay? And should not be contested any further. I would hope that piece of data, solid. What conclusions we draw from it, still up in the air. If you filled out the form, you noticed there was a spot on there for shout-outs. Now, the following people contributed. These people all contributed and said they would like to hear their name on video. So Wonderwall, Ion, Jess, Fritz, Ziploc, and Nick and Friends all participated. Every one of those people sent in at least one data set, several data sets in some cases. So these are real scientists out there doing real observations. And so that's kudos to you. I don't know if you have YouTube channels. If you're on this list here, that's because I don't know what your YouTube channel is. Hit me down in the comments down there and let us all know if you do have a YouTube channel, and we'll link that. And then I want to get you onto my featured channels page. Here's the list of YouTube channels that I do have a link for, and that would be Critical Think, Cambridge Skeptics, The TT Guy, Where's Wally, and Rusty the Robot Bear. I have featured each of these channels on my YouTube page, and let's take a look at these right now. Let's take a quick look at those YouTube channels right now. Critical Think, first on the list. What do you got for me? Critical Think, excellent channel I've been following for quite some time. Focuses mostly on debunking of flat Earth. So yeah, that's a debunk channel, but it's really an exceptional one. I advise you to check it out if you have not. He does real calculations, real experiments. He goes out there and does the experiments and he shows the results. And he does so with a little tongue-in-cheek, but also, I think, still quite respectful. So even if you're if you're a flat earther, you know, especially if you're a flat earther, I think it's worth a check. Just actually watch one and listen to what the other side is saying. You know, give them a chance. Give them a chance out there. So a lot of fun. Critical Think. Check it out. Who else we got in here? The TT guy. The TT guy is has got some good debunking stuff on here as well, and a good attitude. And check it out. Incontrovertible proof that Earth is a sphere. Doesn't that sound interesting? If you're a flat earther, especially, maybe you're not going to find this incontrovertible, but why don't you go check it out? Give it a watch and see what the other side is saying is incontrovertible. Am I right? And I like this one as well. Should we see a curved horizon? A lot of what we hear from the flat Earth folks is that I look at the horizon and it's flat, it's level, right? It's flat. Yeah. The thing about that is we agree, right? Like we agree on that. That's not a reason to say the Earth is flat. It doesn't create a difference. There's no difference there between the globe prediction and the flat Earth prediction. And he goes into why that is. Give that a look. Try to understand, right? Try to understand what the other side is saying. I think I have shown that I'm going to some lengths to try to understand your side. And I think when you watch Critical Think and when you watch the TT guy here, you're going to see, yeah, that they have made an effort to understand what you're saying. Now just take a pause and listen to what they have to say about it. All right, who's next? Where's Wally? Of course, Where's Wally is another debunker from down under. Critical Think is from down below as well. Where's Wally also from our southern hemisphere, and he focuses on debunking, which is mostly responses to what the other side is saying, what the flat earthers are saying, and he responds to those things. So check that out. Rusty the Robot Bear. Rusty is a really good guy who, tons of respect, patience, and he's got a really great attitude about all of this. You can see here that he's been interacting with Raichi recently, and here's some responses to Riley. Check this out. He's got very respectful responses to your questions, and if we just keep that dialogue going, I really want to encourage that. So that's Rusty the Robot Bear. And also Cambridge Skeptics. Now, I was not aware of Cambridge Skeptics before this, but now that I have encountered Cambridge Skeptics, I'm going to spend a weekend going through all of this stuff. This is great stuff, and I want to dig through it. They did their measurement, their solstice measurement, at the Bedford Levels of all places. Bedford Levels being famous, of course, for Robotham and his level water experiment. I find that one really interesting. If you haven't really researched it, please do, especially if you're a flat earther and you go around saying, oh, the Bedford Levels proved the Earth was flat. Read the rest of the story. Read what the Globers had to say about that, and find out, because there's more to that story. There's a follow-up, and it's worth doing. So they went to the Bedford Levels to do their solstice observation and managed to get the sun to squeak out just in time to get the observation. So great video also that they put together. They look like a fun group of folks. So like I said, if you've got a YouTube channel and you want to shout out here, let me know what the channel is and we'll get that done. I want to get you on my list to make sure everybody knows that you folks are out there doing real science. This is real science that we're doing. It's a real observation. What do you hear all the time? You hear observable, repeatable evidence, right? Well, here we are. We're doing it. This is observable, repeatable evidence, and that's what it's all about. So next time I'll be back. We'll take a deeper look at what we can learn from this data set and see what there is to see. In the meantime, look down in the description for all of these links to all of these channels, but also a link to that spreadsheet that I just showed. You can grab that data and use it as you want. Okay? All right. See you next time.